Welcome to ZKast, everybody. I'm ZS Caraval from ZK Research, and I'm here for another thought leadership video. I'm here today with Jonathan Wright, who is the Chief Technology Evangelist at Eggplant, which is a Keysight company now. So, Jonathan, before we get going, why don't you just do a quick intro on yourself, who Eggplant is and who Keysight is?
Wonderful. Well, thank you so much for having me. I'm a big fan of the series. Looking forward to kind of exploring today's topic with you. So yeah, I'm Jonathan Wright, and I've been doing automation for 25 years now in the thought leadership area. I did a TED talk on cognitive learning around what our discussion part today around digital twins. I'm actually based out in Oxford in the UK, part of the Eggplant family. So I've been working with them now for a while, heading up their R&D capability for some next generation platforms. Of course, everyone knows or should know Keysight. It was originally Hewlett and Packard in 1938 with the founding of the Silicon Valley in that garage. They were building test equipment, and of course, I think Keysight's known more for that same Bill and Hewlett Packard kind of landscape than they are in the software landscape. So it's going to be exciting to talk to you today about software and hardware.
Yeah, it was interesting seeing when Eggplant was acquired by Keysight. I was a little surprised, but then it made sense. Eggplant being one of the leading software test companies, Keysight being one of the leading hardware testing companies, and this concept of full stack testing, I guess, is something you can bring to bear now. Now, as you mentioned, we're going to talk about digital twins and how it's used in software testing. Before we start, though, I do want to give a quick shout out to eWeek. eWeek is my media partner, and all ZKast are done in conjunction with the eWeek eSpeaks program. So, Jonathan, you actually echoed the term first, the digital twin. Before we start, though, this is a term, I know it's widely used in a number of verticals. It's been around, a fairly long time in aerospace and things. So for those maybe not familiar with digital twins, what is a digital twin? Who uses them and why?
Yeah, fantastic question. And there is a lot of confusion. And I think it's because when we think classically of a digital twin, we're thinking about a physical object, something that you can touch. And, it started off, I guess, replicating some of those physical systems in a digital manner. And then it's been extended out. So it extended into kind of, I guess, software. So things like network digital twin is something you might be familiar with hearing. Yep. And then eventually all the way up to kind of the protocol and application stack. The term digital twin, of course, it seems to be trending. It's one of those things a lot of people are talking about. I spotted an article in Oxford Press, which they released a couple of weeks ago, talking about a digital twin of yourself, what would happen there. And, this kind of transcendence kind of viewpoint of, could we replicate human beings? And I think that may be a long way away. I think we're still at that fundamental part of talking about digital twins for hardware and elementary software.
Yeah, that's, when I first became familiar with it was years ago when I think it was Boeing that was using the test jet engines. And it made sense that, the cost of building a secondary engine is quite high. So if I could build a virtual version of it, run simulations, that makes sense. Now, I do know that the use cases of them have grown. They're used by autonomous driving companies to be able to test, how cars run on roads. It's become part of the metaverse. So who knows, maybe next year at this time, our digital twins of ourselves will do the next ZKast. So now it is being brought to software, which is what you're doing. And what's going on in software testing? Why do we need digital twins in software testing?
Yeah, it's a great question. And I think part of software is it's not measurable as easily as physical objects. That is a silicon level down to kind of, I guess, the traditional Keysight testing of, measurement. It's down to a voltage and, everything is down to the nano level, I suppose. Whereas, when it comes to software, we find it quite difficult to express software in the same way, how software works. And then we add in all of this additional complexity and we kind of just expect in the real world that it's just going to work. And I know both of us were at CES this year, and Keysight launched their autonomous radar emulation, which was kind of, okay, we need to learn, I guess, two things. We need to be able to emulate, maybe using digital twins and simulators. And then that simulate component is bringing emulation along with it, in the sense of, instead of actually testing an autonomous Car2X, infrastructure 2X piece of equipment, you can actually sit there and simulate and emulate the radar system as lots of objects are, popping out on the road. And therefore, you're not reliant on just that simulation of something which you're expecting to work, and that doesn't obviously work always in the real world, which is why we get all these fantastic stories, things like Tesla Autopilot, where, of course, there's going to be, I guess, still bugs in the system. And how do we potentially look at that from a software decoupled from an abstraction from the hardware?
Yeah, so is it that this kind of decoupling of hardware software that's made it possible to do digital twins and software testing got more complicated? Because frankly, software testing has been around as long as we've had software, right? And we haven't really applied this to it until recently. And so I guess I'll ask you this way, is software testing today significantly more complicated than it was even a few years ago?
I think it is. I think, I think we're, like you said, abstraction. We're so used to things like HAL, the hardware abstraction layer. We're kind of abstract things to the point where we can understand them, and therefore we lose all that complexity. And I think that's the problem, is we know software's complex. We know it's continuously evolving and changing, and we've got this appetite to release faster. Therefore, how do we know the difference between system A and system release B, and really be able to understand and measure that in a little bit more of a scientific manner? And I think this is where we're starting this preliminary kind of stages of starting to model things like network digital twins, which I'm going to kind of add in some of the stuff around we did around for scalable networks. So we creating digital twins of, digital battlefields, for instance, understanding the satellites, how all the ships are moving, how all the, the hardware's communicating from a protocol perspective. And then the logical next level is the application stack. And you're absolutely right. Complexity of that just continuously increases at an X factor. Back in November, Steve Wozniak announced he was doing live from the labs. He talked about Salesforce, and we created a digital twin of the Salesforce blueprint. And we were able to show how we could create that in a matter of minutes, and then generate all permutations of kind of tests against your unique kind of DNA of Salesforce. And everyone's, has their own way of implementing business. So, your ERPs and CRMs are obviously famously known for having so much customization and so much complexity. So just trying to test them without understanding all the business rules and everything else underneath is actually quite problematic.
Yeah, so I know, and so this is something that's relatively new to your portfolio. So describe how Eggplant and Keysight are bringing digital twins to software testing, and what the role of AI is in that, and just describe how that works.
Sure. So I'll probably give you the best example. I was flying over to Zurich today, so I'm speaking at the Swiss testing days tomorrow, and I thought, okay, I'm talking about digital twins. I should really show them how it works. And so I'd literally just pulled up our Keysight website, and I kind of started using the website just as an end user would do. And then what I did is I then looked at reversing that into a digital model of all the people using Keysight. I think it was in about an hour. It was at 6 a.m. this morning. The last hour, I took a snapshot of all the usage on the website, and then I created a digital twin of the model and try to show everyone, today's this is the timestamp. This is the exact route I went through the system and explored the system as an end user would. And now I've created a digital twin of all of those possible kind of routes that our people are doing. And then, of course, it's not a massive jump to then use things like machine learning to extend that to try to do some exploratory, to kind of look at all permutations. And we talk about things like model-based testing, which again has been around since the start of time, I suppose. And there's different types of pairwise testing where you can go through and try all paths with all different types of permutations. Now, we know that's not the real world. We can simulate that and simulate millions of different permutations of people going through the system. However, when it comes to a real user, like I was, this morning at the airport, I was on my tethering on my phone. I had a poor connection. The page, had over 8 meg on Keysight's website downloading all these different JavaScript elements running in the background. That actually my experience was very different going and navigating through this system. And what we call metamorphic testing, which is kind of jitter, all these things where people hit refresh, they kind of have a strange configuration or they navigate in a particular way, which is kind of unusual. We're actually able to record those kind of journeys and then create models that simulate the kind of more realistic viewpoints of how people go through that system and have a different experience each time. And I think that's just early stage. You can apply that to anything. You can apply that to different environments. You can apply that to a mobile app or a system which you're testing, or a system under test, and it'll listen at the network layer, the protocol layer, and also the application layer, and understand all of those digital interactions and then model them out as a kind of a unique DNA of how your software works.
Now, I imagine the use of AI long-term would make digital, when in fact you probably have to use AI as part of digital twin. But so what's that, does that make things initially more complicated though? How does it, because it would seem that there's an initial learning phase and, training period, things like that for the company to go through. So how do you kind of mask that complexity and make this usable for customers quickly?
Yeah, great question. And usually especially when you're talking about kind of AI-based systems, it needs a large training set. And so the more data you can feed it, the better you can get.
And more good data, right? Because good data leads to good insights, but bad data also, right? So, but although I guess the bad data does help with the training too, to not know what to test, right? So. Yeah.
Exactly. And it's interesting because most people think that in the real world, every permutation of a system is taken. But in actual fact, only 20% of most functionality is actually used by end users. So actually, you're observing behavior, which is completely different. You're releasing features, which, only a small amount of people may use. They might be time sensitive, so they might be only happen at the end of the month. So you've got to observe a huge amount of data. But what we do within kind of our proprietary algorithms is we kind of look at things like bug hunting. And so what we'll do is we'll what we refer to internally as feature cluster, which is kind of look at a route, which could be a positive outcome. So let's say you just want to change your address. It's not revenue generating, but it's still critical because you need to be able to do it as part of a process. Now, if you found that actually when you changed your address, because you just moved, from East Coast to West Coast, and then suddenly, something's not working, it can start going, actually, I understand all the locations where that zip code is being applied through the system, whether it be the enhanced transforms and loads that are happening overnight or, certain parts of the system. And then it will go off and understand the relationship and see if typically there's this kind of rule of thumb. If there's a bug, there's a good chance there's another bug behind it. So it starts focusing on there and exhaustively testing it with different permutations, different types of scenarios, because it's found it in one part of the system. There's a good chance that it's that same bit of code or the same feature in another part, and therefore that's still got a problem. So things like the AI bug hunting and exploratory testing are fairly easy to implement. Whereas what we're now getting to is, okay, how do we understand whether or not your system's ready to go? Because, unlike hardware, which you've got some kind of CE stamp at the back to assure it of some level of quality, you don't know, because you're now using a SaaS platform, A, what version it is, and B, whether it's as stable as the last release that they've done or the release before. And I think we're now getting into this kind of chaos engineering landscape of how do we test things, do dark launching and canary rollout at scale, and then be able to understand the quality of what the actual product is and how it's increasing or decreasing over time.
Yeah, and so thank you for that. Now, can you give me an example of a customer or two that's actually using this product and what kind of results they've seen from it and how it's helped them?
Yeah, so I got a great example. During COVID, I was working with MIT for the the contact tracing. And it was one of those kind of problems of how do we create a digital twin of people, interacting with each other and moving around locations, across, let's say, London or Santa Clara. And so in that particular case, we used, some base data, which was actually my Google Takeout data. And then we synthetically generated 2 billion possible routes through, different streets, through different areas and different interactions. And then we simulated at scale, what would happen when we run this at a certain frequency as far as the polling of the actual where your GPS location is, which was sampled, I think, something like 7,000 times a week based on just an Android device. And then we simulated that running instead of having to go in the real world of would it actually give you false positives? And then we then ended up working with Apple and Google on the Apple and Google exposure or gains, Google and Apple exposure notifications, which everyone's now got on their phones. And of course, everybody knows that isn't GPS anymore. That is actually based on Bluetooth and Bluetooth proximity. So that's fine if you kind of know the Apple devices. But when you start looking at things like Android, there's different devices, different Bluetooth with different signal strengths. Therefore, whether or not you're walking in a different room and that happens to pick it up because it's not being calibrated to the same area, there's hardware and software. And therefore, we needed to then be able to start introducing this, how do we test the physical hardware, not just abstract it, but actually try it on different permutations and see if people would get flagged who potentially was, traveling past somebody or, going past somebody very quickly. So we tried all these different permutations. And again, we created a digital twin of all of those different types of scenarios, which only took about 5 hours for the system to generate, but it had over 10,000 different permutations and edge scenarios, which allowed us to kind of battle harden it before we're actually taking it out to Haiti and looking at observing the real world's adoption of Google and Apple exposure notifications.
Yeah, that's pretty cool, because now you're starting to test things that if you tried to do in real life would be virtually impossible, right? To try and simulate that with actual people or build models of that. Also, I was at an event last week and we were talking about this concept of the metaverse, and I was questioning whether there's any actually good use cases for it, but I think the one you described actually is a pretty interesting use case for what we could do with something like the metaverse, right? Where we can use it for simulations in order to test things like that. So that's are you trying to marry those things together?
Yeah, so I actually had a call with the Meta team because they're doing what they refer to as Edge Meta, which is kind of this, I call it a CDM, but it's like a last mile infrastructure so that everyone can interact with each other, know whether you're, where you are at the moment today or all the way in Zurich. We were able to interact within a certain amount of response time. But, being in that kind of three-dimensional kind of, real environment is completely different. And it's a lot easier not to know whether or not, that you're lagging or you're causing a problem because people are jumping around. So what we actually did is we're working with people like Microsoft at the moment on their kind of HoloLens technologies as well for mixed reality, is we're doing things like eye tracking. So we're emulating the movement of an eye. So as we know, at the Google I/O conference recently, they're going to release mixed reality Google V2 headsets. So are Apple going to be releasing Apple glasses, both using eye tracking technology as well as your directional movement. So you can be moving your head and the gyro can pick it up, but then you can also be moving your eye and then the text be moving across because that's where your eye tracking is. And then you obviously from a LiDAR kind of perspective, you're understanding depth, you're understanding how that overlays onto the real world. So, whether that be navigation or some other kind of feature that you're actually wanting to use in a mixed reality landscape. But more importantly, where we've come in from a classic Keysight perspective is things like, well, what's the temperature? What's the battery drain? What happens if we put it in an environmental kind of position? I think that you had a great example, I think, with twilight testing. How do you simulate light? So within a certain area, there's the accuracy drops. How do you ensure that for critical systems such as the battlefield, how people are actually able in the desert be able to repair military equipment or critical infrastructure when there's kind of these war zone kind of scenarios. But then from a consumer perspective under kind of Meta, again, they're looking at quite ambitious 6G kind of rollout of this technology, because we're going to need to have kind of what 5G gave us for the IoT landscape, but have this ability to do even lower latency, so people can move around in this kind of environment. They can work and collaborate. Of course, the Oculus Pro devices are going to move into that mixed reality landscape. But of course, there'll still be VR, there'll still be the metaverse aspect where people might be collaborating within some kind of virtual environment, which, I think we're starting to see a lot more of the consumerization of VR and MR. And obviously, we've seen the AR kind of mobile kind of adoption, and being able to test the hardware and the software, and then all the 6 directional kind of, controllers, your hand movements, your cameras, what your eyes see, your tracking, your body tracking. All of this creates a digital twin. It's not just, let's just test the headset. Let's test every single part of the experience and see if that actually your body believes that you're in that environment, instead of maybe, the first or second generations where you were still kind of feeling that a bit sick, a bit nauseous, a bit kind of resistant to that kind of environment.
Yeah, actually, that was a very comprehensive. Now, one of the reasons I like actually talking to Keysight is because you build test equipment for what's next, right? Which means that in order for you to build your product, you have to be looking at what's not just next, but after that, right? So you kind of foreshadowed 6G. What are the other kind of things that you're working on today to build digital twin, for that, people may not even be aware of that's coming, but, you obviously have to, because you deal with things that are so far in advance in the future.
Yeah, so we've known for a long time kind of autonomous vehicles are exactly what they say, autonomous, right? It needs to be Car2X. It needs to be, the ability to actually communicate with other cars, other infrastructure to X components, smart city, in essence, communication.
How far are we from that?
But even further than that, part of this kind of viewpoint, and within my TED talk, I've got this ridiculous, crazy video in the background, which is kind of saying how, we're going to be collaborating in same space areas. So, there'll be certain kind of areas within your city where you'll go sit down in a shared space, collaborate with other people in a virtual way, where you're using things like mixed reality in this metaverse kind of area. But actually, this will be kind of a completely different way to what we've seen kind of the gig economy, I suppose, take up. We're going to see things that, you would not expect, a very kind of science fiction kind of landscape. So I think 6G, yes, is going to be a game changer. I think there's going to be a lot more edge compute and edge AI that we need to do, a lot more processing that needs to be done locally on the devices, and less reliance on cloud. I think there's a lot of that, and therefore network is absolutely critical for that, in the sense of how do we lower that kind of barrier of entry for, that last mile, because people are still, struggling with having a really amazing digital experience. And I think this is where I know we started, with this kind of transcendence, with obviously another Johnny Depp kind of reference, but where you're able to literally download your brain. As a Neuralink from obviously Elon Musk and stuff, we're seeing that kind of technology of, well, how do we deal with human computer interaction when, the barriers are completely changed. We're not using screens anymore. We're not using mobile devices anymore. Kind of, well, how do I interact? How do I, how do I accelerate? And I'm going to say, you can get a superpower, which you can use for your work, or, to be able to process huge amounts of data and do much more with less, and less reliance on the digital grind, emails, things that, really we shouldn't be dealing with anymore, and actually start using human brain power and collaboration of thousands of people in a single day. I did a talk, I think it was in 2011. In 2011 years were spent reading emails just in the US alone in that calendar year. You're thinking, well, all that brain power should be put together to move human evolution forwards. And this is this kind of evolution over revolution. It's going to be a collaboration for, I'm not going to say the greater good, but, it's a kind of a Star Trek kind of fantasy of all coming together just in time to work on projects to solve complex problems, and break down all of those barriers which we had before.
All right. Well, Jonathan Wright, that's quite a painting of the world. So if you're watching this, we have digital twin, 6G, edge computing, mobility, all of it coming together to, frankly, solve some of the world's biggest problems, but also help businesses solve some smaller problems, right?
Absolutely. Well, it's been a pleasure.
Yeah.
And I'm looking forward to the next episode.
Yeah, no, thank you very much. And on behalf of Jonathan, I'm ZS Caravallo. Don't forget to click subscribe, and I'll see you next time on ZKast.